Alright, for fission and fusion, we're going to use the same formula that we used when we calculated binding energy. This is using Einstein's mass equivalence formula. So energy equals change in mass times the speed of light squared. The only difference between fission and fusion and when we calculated binding energy is binding energy was looking at the individual protons and neutrons that combine to make a nucleus. Now what we're looking at is taking a nucleus and splitting it in fission into other products to release energy, or we're taking individual nucleus and combining them together to create a bigger product in fusion to release energy. You still have to balance the reactions, and you still know that the energy of the products, to cause that energy to be released, the energy or the mass of the products is less than the mass of the reactants. So there will be some mass lost. That lost mass will be converted into energy using Einstein's formula. So what we're going to do is find the change in mass. So to find that, I'm going to first of all find the mass of reactants. And that's going to be one neutron, 1.6749 times 10 to the negative 27 kilograms, plus the mass of uranium, 3.9029 times 10 to the negative 25 kilograms. I tend to do this in parts just because of the numbers. Put it all together, you seem to always make a mistake with your numbers. 1.6749 to the exponent negative 27 plus 3.9029 to the exponent negative 25. You should get 3.919649 times 10 to the negative 25 kilograms. We tend to not worry about significant digits because these tiny little numbers, a little change in those numbers really affects our answers. Let's find the mass of the products now. That's going to be barium, so it's going to be 2.3421 times 10 to the negative 25 kilograms, plus krypton, 1.5239 times 10 to the negative 25 kilograms, plus 3 times a neutron, 1.6749 times 10 to the negative 27 kilograms. Remember, there's 3 neutrons here. So let's add those up. 2.3421 to the exponent negative 25 plus 1.5239 to the exponent negative 25 plus 3 times 1.6749 to the exponent negative 27 enters 2.49147 times 10 to the negative 24 kilograms. I just punched in my answer one more time and realized that this is not the right number, so I'm just going to do a quick erase here. The reason why I noticed it is because I ended up with times 10 to the negative 24. So as soon as I ended up with the mass of the products being bigger than the mass of the reactants, I knew I did something wrong. So when I recalculate this, I should end up with 3.916247 times 10 to the negative 25 kilograms. And the reason being is because I just punched in my mass of the neutron wrong. I suggest punching that in first, 3 times the 1.6749 times 10 to the negative 27, then add the other two numbers to that answer, and you should get this result. The mass of the products must be a little bit less than the mass of the reactants, and I have that. So to find the change in mass, take those two numbers and subtract them. 3.919649 times 10 to the negative 25, subtract 3.916247 times 10 to the negative 25, and your change in mass should equal 3.402 times 10 to the negative 28 kilograms. So before I go to the next slide and finish this up, because I don't have enough room, I found the total mass of the reactants, found the total mass of the products, and then what I did was find my mass lost. Always the reactants, subtract the products to find your change in mass. On the next slide, we can calculate how much energy that was. Going to Einstein's formula, E equals change in mass times the speed of light squared. E equals 3.402 times 10 to the negative 28 kilograms. Multiply this by the speed of light squared, 10 to the 8 meters per second squared. We'll figure out how much energy this is. Times 3 to the exponent 8 should give you energy of 3.0618 times 10 to the negative 11 joules. I'm going to change to electron volts, times 1 electron volt, 1.60 times 10 to the negative 19 joules. So the energy in electron volts works out to be 1.91, huge amount of energy, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 electron volts, or easier written as 191 mega electron volts. Mega being times 10 to the 6 electron volts. Huge amounts of energy released in fission in this case. So be careful to calculate your mass of the reactants and mass of the products. Find the mass lost in the reaction, multiply it by the speed of light squared to find the energy. That's going to be how much energy was produced in this case. Fission is always the process of splitting a very large nucleus into two smaller nucleus. Also creates a bunch of neutrons that can continue this process going, and it'll increase exponentially because you create 3 neutrons, and you get a whole pile of energy as a result.